Hi, Math 1 Shasta High School. This is Mr. Roberts. I'm going to look at just two quick examples from your homework assignment. The first four problems you had to do tonight involve solving a system of equations using graphing techniques. I've already written down the solution to this one. It is x is 2, y is 4, but I want to show you how I arrive at that. One of those two equations is super simple to graph. It's the line y equals 4. And if you think about it, anywhere I move along this horizontal line, all the y points here are equal to 4. So it's just that horizontal line. Let me grab my ruler, line it up, and just draw that line. That's the line. It's supposed to be the line y equals 4. The other line, you can see I've got a y-intercept of -1 and a slope of up 5 over 2. So if I'm right here at -1, then I can go up 1, 2, 3, 4, 5, and then over 2. So actually that's this intersection right there where the two meet. I'll go ahead and draw this other line so I can look at both of them. But here's my second line. And the equation, well, the point of the solution here is this point. That's the one point that makes both of those equations true simultaneously. And it happens exactly when x is 2 and when y is the number 5. So that's why 4. 2 comma 4 is my solution. The other problem that we're going to look at is on the second page, question number 5. It says solve this system of equations using the method of substitution. It's a little difficult, but I hope seeing this again kind of assists you in doing these. One of the things we said in our notes today was that we begin by getting either variable isolated in either one of the equations. It doesn't matter which equation. It can be the first one or the second. And it doesn't matter which variable. It could be x or y. But I need to get one of my variables by itself. Now, as I look at this, it's clearly pretty simple to isolate x in the second equation, right? In fact, I'm going to do that by simply adding 7y to both sides. So if I add 7y to both sides of the second equation, that becomes x equals 7y plus the number 26. So you can see now x is by itself. What I do now, right, is we're going to take this value of x and we're going to substitute it in for x in the other equation. So in other words, this is x. This thing right here is equivalent to x. And I'm going to place that in the first equation right here where x is. So I'm going to write down this equation. It's 6 times what x is. Well, x is this big old binomial, 7y plus 26. So it's going to be 6 times, this is x, 7y plus 26. There we go. There's 6 times x minus 8y equals the number 20. I'm going to use the distributive property here to get rid of the parentheses. Of course, 6 times 7 is 42. So I've got 42y. And I also need to distribute the 6 to the 26. 6 times 26 equals, that's 6 times 26 rather, is 156. So plus 156 minus 8y equals the number 20. I'm going to combine a couple like terms. On the left-hand side, I have 42y and negative 8y. If I take 42 and I subtract the 8, that gives me 34y. So I have 34y, not 3y, 34y plus 156 equals 20. And what we're going to do now is from both sides, I'm going to subtract 156. Subtract 156, subtract 156. So if I do that, on the left-hand side, the equation is now 34 times y. I keep writing 3y. 34y equals, and I'm looking at 20 minus 156, which is negative 136. If I divide both sides by 34 now, it doesn't have to be a nice integer, but in this case it is. Y is equal to negative 4. So I now have the value of y. The question still is, because I'm trying to find an xy pair that makes both equations true simultaneously. What I'm going to do is I'm going to take this value of y and I'm going to substitute it way back in up to the very beginning. Because if you notice, I had this expression that says x is equal to 7y plus 26. So if we just take that expression, 7y plus 26 is x, or that equation, 7y plus 26 is what an x is. And I'm going to plug in the y that I have. So x equals 7 times negative 4 plus 26. 7 times negative 4 is negative 28. So I've got here negative 28 plus the number 26. So it looks like I think x is equal to negative 2. So my solution is this point. X is negative 2 and y is negative 4. So there's my solution to this problem. I'm going to come back up here and look at my original problem. In fact, I'm going to erase a little bit of this stuff right here. And I want to just quickly check this using some simple arithmetic. So if I have 6 times negative 2, that would be a negative 12. And I'm going to then subtract from that 8 times negative 4. So I'm going to subtract from that a negative 4 times 8, which is 32. And I'm going to subtract a negative 32, which means I'm adding 32, right? Because it's negative 8. Let me write this all the way. I'm sorry. I've got 6 times negative 2, that's 6 times x, minus 8 times negative 4. So you can see here this is negative 12, and we're going to be adding 32. And when I combine those two, I do get positive 20. So it works in the first equation. In order for it to be a solution to the system, though, it must work in the second equation. So I'm going to plug in these values into the second equation as well. I'll do it here. So I'm going to have x, which is negative 2, I think, minus 7 times negative 4, which looks like negative 2 plus 28. And negative 2 plus 28 is indeed 26, which is what it's supposed to be. So it works for the second equation as well. So again, my solution, and I checked it, is x is negative 2, y is negative 4.